Hello everybody. Today we start with a new chapter in 9th standard chemistry ICSE, that is the first element of the periodic table, that is hydrogen. Now hydrogen is the first element because the atomic number of hydrogen is 1. That means the atomic number is equals to 1. Atomic mass is also 1, so therefore the protons are 1, electrons are 1, neutrons are 0. Now of course this is only when we are talking about hydrogen, we are not talking about the isotopes of hydrogen. We know that the isotopes are, there are 3 isotopes of hydrogen, in which one has got 0, another one has got 1, another has got 2. Accordingly the mass will be 1, 2 or 3 for protium, deuterium or tritium. So these are the 3 isotopes of hydrogen. Electrons are only 1, therefore electronic configuration is just 1. That means it has got a atomic structure like this, just 1 electron in the outermost, in the first shell of this particular. So we can see the valency of hydrogen can be +1 because it can give away or share its electron with somebody, or it can accept 1 electron, so -1. So the valency over here can be equal to +1 or -1, and that's the reason it can be placed. You know that in the periodic table the +1 are all the one which are group 1, and this are all which are group 17. So these are alkali metals and these are halogens. So we know very well that the group 1 are valency +1 and group 17 are valency -1. So that's why the position of hydrogen in the periodic table is under a question mark, whether to place it in group 1 or group 17, or we can say that it can be made, its properties are such that it can be put into any of these two because of its certain properties, where it can be used as a halogen also, or it can be used as a reactive metal also. So accordingly you have this particular thing. So let's see, let's start with the chapter, the position of non-metal hydrogen in a periodic table. So yeah, we are considering it as non-metal because it's gaseous in nature and actually does not give away its one of the electron to anybody, because if it is able to give that thing, then it will become 0. So then we cannot say that it is stable, it is completely stable, because for it to be completely stable it needs to have a duplet or a octet. So 0 ho jayega to duplet to nahi banega, but yeah, so that's it. So position of the hydrogen in periodic table, atomic number of hydrogen is 1 and the number of valence electrons is 1. First element of the periodic table placed in group 1 of the periodic table, group 1 in period 1 of the periodic table. So that gives us a dual nature of hydrogen. Hydrogen has the simplest electronic configuration of 1 and hence either loses 1 electron behaving like electropositive alkaline metals, that is H minus E. So it can form into H minus 1E to give you H plus. So this is one condition, like the one in case of sodium also, you can see Na minus 1E gives you Na plus. So similar to sodium or lithium or potassium, hydrogen also behaves in the same manner. So that's why it is given that Li minus 1E giving you 1 Li or Na minus 1E giving you Na1 plus. And it also can gain 1 electron behaving like an electronegative halogen, it is group 17, that is similarly to this will be H plus 1E will give you H minus, similar to Cl plus 1E giving you Cl minus 1. So 1 minus or 1 plus, 1 likha nahi likha farak nahi padta, but at least that is the thing, that chlorine will be 1 plus 1 electron will give you Cl minus. So resultant position of hydrogen, so hydrogen does show similarity with alkali metals of group 1 or halogens of group 17 or 7A, and is placed above lithium in group 1A and above fluorine F in group 17 or 7A. So let's see the properties which make it similar to alkali metals and halogens. So let's see the properties one by one, which is going to see to it, or we can just confirm that yes, it can be in both the positions. So let's see the first one, that is the similarities of hydrogen with alkali metals. So we have that the electronic configuration of valency is equals to 1, similar to that of hydrogen, which will be similar to lithium, which is 2,1, sodium, which is 2,8,1, potassium is 2,8,8,1. So it has got a similar electronic configuration of having only one electron in its outermost orbit. Second is the character wise. Yes, we just saw that hydrogen can lose one electron to give you one H plus. So similar to the sodium, potassium, lithium, it can lose one electron and become plus one ion. Valency, it is electrovalent of exhibiting valency is 1 because it is H plus, H1 plus, or Li plus 1, Na plus 1. So similar to that. Now reaction wise, it has a strong affinity towards non-metals. Now you will always find that Na is going to form a salt with NaCl to form HCl. Similarly, so similar H plus H2 plus Cl2 will also give you 2HCl. Similar to Na plus Cl2 giving me 2NaCl. So you can see the similar things like hydrogen reacts with non-metals to give you a chloride or an oxide or a sulfide of this thing. So hydrogen forms water, hydrogen sulfide, HCl, similar to the sodium forming Na2O or Na2S or NaCl. Next is reducing agent. All the alkali metals are reduced. All these are alkali metals. So we are talking about here alkali metals. So all alkali metals are very good reducing agents. Okay, they are very good reducing agents because they themselves get oxidized. So similar to that, hydrogen also is a very good reducing agent. If I have got copper oxide and if I reacted with hydrogen, so we know over here that CuO plus H2 is going to give you Cu plus H2O. So it's a very good reducing agent, similar to any other like potassium and all, who are the same particular kind of reaction, will give you Cu plus Na2O. This is a simple thing. Similar thing in case of alkali metals. So hydrogen behaves, you can see over here with all these equations, it is exactly the same as what is happening with potassium or sodium or lithium. So that's why we can consider that hydrogen is also an alkali metal. So all these properties, so hydrogen has got all the properties of a alkali metal. Now let's see the properties what the hydrogen has got connected to the halogens. So the next one are halogens. So when we talk about halogen, so first thing is we know very well that H plus 1E will give you H minus. So first thing is the electronic configuration is just 1, that is 1 less than the nearest noble gas. So similar to all the others, like for example, you know very well that fluorine is going to be 2,7, so it just needs one more to become 2,8. 2,8,7 is chlorine, which is just adding one more to give you 2,8,8, hence it becomes argon. And so you can see that similarly hydrogen, if it gets one electron, it will form into a electronic configuration of just 2, which is of helium. So you can see that the hydrogen also has only one valence electron. If it takes in one electron, then automatically it will have the electronic configuration of the nearest noble gas. Second, so ion formation, we know, so it will be H plus 1E will give you H1 minus, and similar to fluorine and chlorine, doing the same kind of a process. Valency wise, electrovalency and covalency exhibit. So hydrogen is going to form with sodium. So normally we will find that hydrogen can form an electrovalent bond as well as a covalent bond. So similar to the halogens can form an electrovalent bond as well as a covalent bond. So we can see that hydrogen can form electrovalent. So electrovalent bond wise, you know that H plus Na is going to give you NaH. So H2 plus N2Na to 2NaH. So this is going to be the formation over here. At the same time, it can also have a covalent bond. So in a covalent bond, you know that C plus H2 is going to give me CH4. So there is a covalent bond formed between the two over here. This is similar to the chlorine also. Chlorine also happens the same way. Over here, chlorine ke kaise rahega? It will be Cl2 plus 2Na will give you 2NaCl, or we can say over here also C plus 2Cl2 will give you CCl4. So that is nothing but carbon tetrachloride. So we see that they are going to form, like in case of hydrogen, they are forming a compound similarly as it could take place in any halogen. So that's why hydrogen also behaves like a halogen. And the next thing is the atomicity. All the halogens have got the atomicity 2. You always call I2, Br2, F2, Cl2, okay, because they are diatomic structure. Similarly, hydrogen 2 is a diatomic structure. हम लोग ने यहाँ पे H2 लिखा, right? H2 यहाँ पे लिखा, okay. So hydrogen is a diatomic structure. The structure is diatomic. Hence, you find that two atoms linked together in a single bond as similar to that is chlorine. So that's the reason the atomicity is 2. So these things, you can see the things over here, we are convinced that hydrogen is a alkali metals. Alkali comes under the category of alkali metal because of the properties. You can easily get convinced over here also that hydrogen is behaving like a halogen. So that's the reason you can say that hydrogen is the one which can be present in both these particular kind of table groups, that is group 1 also and group 17 also. So that was about the position of the hydrogen in the periodic table. The next what we see is about the discovery and the laboratory preparations and everything. So let's start with the other discovery. Hydrogen was initially called inflammable gas. Robert Boyle in 1972 established the elementary characters of hydrogen. Henry Cavendish in 1776 first prepared hydrogen in the pure state and also described its properties and recognized it as an element. He found that the gas was inflammable and that it burned in air to produce water. Lavoisier in 1783 established its name hydrogen, meaning water producer. Hydro means water, gen means generator or producer, that's why it was hydrogen means water producer. So that's how Lavoisier gave it the name hydrogen to the substance. Occurrence wise, in a free state, hydrogen stands 9th in abundance by mass among the elements present in the Earth's crust. It makes up approximately 1% of the Earth's crust. So on the Earth's crust, it is 9th in abundance and it makes about 1% of the Earth's crust. Hydrogen is seldom found in free state on the planet Earth. So on the planet Earth, yes, of course, in free state it is not available much. It's only the crust part that is there. Free state में नहीं होता इतना. It exists up to 0.01% in Earth's atmosphere. It is also found in minute traces in volcanic gases and to a higher extent around the sun and the stars. So in the free state, on Earth's crust 0.98%, Earth's atmosphere 0.01%, volcanic gases 0.025%, and atmosphere around the sun and stars 1.1%. But in the combined state, it is in abundance, right? Hydrogen is distributed in combination with other elements in combined state. It occurs in a combined state in plants and animal tissues, which are made of compounds of hydrogen along with carbon, oxygen and nitrogen. So you can see that hydrogen is going to combine with carbon, oxygen and nitrogen to form most of the parts, or you can say compounds for plant and animal tissue. So plant and animal tissue, we know they are made up of carbohydrates. It will be having carbon, hydrogen, oxygen. If you are talking about the Proteins also, they are made up of carbon, hydrogen, oxygen and nitrogen. So starch, the same thing. Glucose and everything are just carbon, hydrogen, oxygen. All the so basically the plant body, okay, we can say the tissues of the plant are composed of these kinds of hydrogen as a compound. In water, about 1/9 of the mass of water is hydrogen. So 1/9 of the mass is hydrogen as a constituent of different substances. Like we know very well that in acids, okay, all acids have hydrogen. All alkalis, so acids, alkalis, petroleum products, organic substances, all of them have got hydrogen in a combined state. So acids, all HCl, H2SO4, H तो होता ही है acids के अंदर. Hydroxides which are formed by hydroxides which are alkalis, so will have hydrogen and okay, OH होता है, so that will be there. And all petroleum products like methane, CH4, C2H5, so जो भी H is going to be there. Combined in carbon, hydrogen, it is found in natural gas, kerosene, gasoline, petroleum products. It is constituent of most organic substances including proteins, carbohydrates, fats, which are essential for all living matter. So you can see that in a combined state, hydrogen is going to be present in a large quantity. Now let's see about the general preparation methods of hydrogen. Now in the preparation method of hydrogen, it is a very simple process. Okay, it's a very simple way that hydrogen is being made. We are just somehow trying to make a simple thing that whichever compound has got hydrogen in it, if some particular kind of a thing can replace that hydrogen, then hydrogen is going to be released. Like for example, if you take water, अगर water में से अगर हम लोग को चाहिए, so if I want to remove, see we very well know that water is H2O. So if something is able to replace this, then automatically we can say that it is going to form into hydrogen is going to be evolved. So that's precisely what we are going to do, and that is we are going to see that how we are able to get hydrogen from, first will be water. So let's see how we get hydrogen from water. Now for this, what we can see is that all the highly reactive elements, okay, we are going to first see the 3 highly reactive elements. What are those? They are potassium, sodium and calcium. Now these 3 are so highly reactive that they will be able to replace hydrogen from water and going to release hydrogen, but in a different manner, where in such a way that even in this case the water over here which will be used can be even cold water. It does not require any heat, it does not require any steam, nothing at all. It can be easily giving out hydrogen without any problem. So we'll see the first, so equation becomes this way, that 2K plus H2O will give over here as 2KOH plus H2. The H2 gas will be released over here. So the reaction is violent and exothermic. So when it happens, it is going to give you a very violent kind of reaction, and the liberated heat ignites the hydrogen. So normally what will happen is that it will burn out into fire. Okay, there will be fire will be generated. Another important thing over here is that when you are doing such a kind of a thing, they are not mentioned in the textbook, but you can note this thing, that if you take a trough of water and you place the sodium in it, you will find that potassium or sodium, they are going to float on top of it. And if it floats, then the point will be that when the hydrogen is going to be evolved, it will be very difficult to collect them. So what they do is that they take the potassium or sodium, उसको हम लोग wire mesh में wound कर देते हैं, so that it becomes heavier and it settles down. Otherwise what will happen is that because it is floating and the gas is being generated, it will act like a rocket thing, you know, that it is going to give out gases and the gases are going to push the water, and that's why the sodium is going to keep on bouncing around, or that is going to be, you know, they are going to be like tracing like this, instead they are going to move around, and it is very difficult to collect the hydrogen over there. So what we do is that they wrap it with the wire mesh so that it sinks down, and then the hydrogen can easily be collected. So that is one of the things what is important. So it will be darting around. Okay, it will be this way, that if this is the structure, this is the top view though, and this is the sodium. So sodium, when it generates the gas, it will push the gas के कारण वो अपना third law of motion के कारण this will be, the gas will be pushing the water will push this sodium, and that's why it will keep on darting. From here it push here, then it push here, push here, push here, ऐसे करके it will keep on darting around. So that's why right, so that's the reason the sodium is going to be put in a wire mesh. The next one, the same thing can also take place with put sodium, so it will be H2O will give you 2NaOH plus H2. So this is going to be the same kind of reaction. So the reaction is violent, and but comparatively less than potassium. The sodium melts into a globule and darts about the water. Hence the collection of hydrogen is difficult. So the sodium is therefore wrapped in a wire gauge and used in the above preparation. So they mentioned this quite clearly, what I just explained you earlier. The next is calcium. Again, you are going to have the same kind of reaction. So it will be Ca, 2Ca plus H2O, giving me CaOH twice plus H2. So this is the reaction what we will be having for calcium. So Ca plus H2, H2O. Now, of course, all these are cold water. These are cold water. You do not require any kind of a heat or any kind of the steam on it. It is just a room temperature water, cold water, and it is going to be giving out hydrogen. But if you take the elements which are lower than calcium in the reactivity series, then the things are going to be slightly different. So the first thing is that if you are taking magnesium, now magnesium is only slightly less reactive, so the water what you take over here will need to be boiling water. So you don't require too much of steam, but you will be requiring a boiling water over here, which will, now magnesium is going to give you MgO. It will not give you MgOH twice, but it is going to only MgO plus H2. So that is the reaction that magnesium is going to. Magnesium, so that is going to give you, and it cannot give you hydrogen with cold water. It requires boiling water. Whereas aluminum, zinc, and iron. Okay, so aluminum, zinc, and iron. If you take these, then it is going to give you Al2O3 plus H2. In this case, Zn will be H2O, will give you ZnO plus H2, and Fe will give you Fe2O3 plus H2. So balancing it are the 2, 3. So this 2, 3, 1, 3, and 1, 1, 1, 1, 1, and 3, 4, 4, 3, 4, 1, 4. Okay, so it is seen that magnesium, aluminum, zinc, and iron do not react with cold water to liberate hydrogen. Magnesium reacts with boiling water liberating hydrogen, but the reaction is slow. Magnesium, aluminum, zinc, and iron reacts with steam in the heated state and form corresponding oxides of higher. So these will require steam. So this is going to be not even boiling water, but it will require steam. So only if it is steam, then it is going to form into the hydrogen is going to be released. Iron reacts with steam, and reaction is reversible. So here the thing is that this is reversible. So when it is cooled down, if this is cooled down, it again forms into Fe plus H2O. So that's why it's a reversible reaction over here. So this is the preparation of hydrogen from water. So here you can see the simple reaction. So we can easily say that the reaction is metal plus water gives you metallic oxide or hydroxide plus H2. This is the general reaction of the generation of hydrogen from water. Okay, so if the metal over here is the first three, you get hydroxide, and if it is the next elements, then it is going to give you oxides. So oxides will be there, and whenever oxide is going to be formed, they will be the one which are going to be boiling water or steam, whereas for hydroxide जिसमें होगा that will be all the ones which are going to be with cold water. Okay, so they are alkali metal. You can see these are alkali metals, alkali earth metals, alkali earth metals. Well, magnesium. So इसीलिए ये जो है there are transition elements. So anyway, you need not worry about that. The next thing we find is that the hydrogen is available in acids. So we very well know that all the acids contain hydrogen. So let's see if what hydrogen is there in each and every acid. So how can we displace the hydrogen from the acid and generate hydrogen? Or we can say, so first thing again, we are going to use metal plus acid. So it will be from acids. So in case of acid, you have got metal plus acid will give me salt plus hydrogen. But here you know very well that if I am using sodium, potassium or calcium, already with cold water it was reacting vigorously and it was creating a kind of a very high amount of heat. So if I am using acid, then it is really going to be explosive in nature. That's why potassium, calcium and sodium react with H2SO4 or dilute H2SO4, but the reaction will be highly explosive and practically not feasible. That's why we are not going to take that thing into picture. So we are not going to take this thing over here, that potassium, sodium and calcium we are not going to use for generating of hydrogen from acids. So that's why we are going to take only the four ones. That will be, the one will be magnesium, next is aluminium, zinc and iron. So these are the one which are going to take. Now over here you can take any acid, you can take H2SO4 or HCl, both are possible. So if you take some, suppose I take over here HCl, over here let me take H2SO4 and here I will take HCl again and then I'll take H2SO4. Okay, so I'm just saying 1, 1, 1 each so that there is you can show it over here. So this can be MgCl2 plus H2. So this will be 2 here. This will become AlSO4 plus H2. This is going to be ZnCl2 plus H2. And this is going to be FeSO4 plus H2. So you can see that in each of the case, you got a chloride salt or a sulfate salt or chloride salt, sulfate salt, and hydrogen gas was being released. So you can have this thing very easily, that whether it is AlSO4 thrice, sorry. Yeah. So this is how you are going to get the hydrogen release from acid. So MgAlZnNFe react with dilute H2SO4 or dilute HCl, forming hydrogen and respective salts. Now here dilute nitric acid will not be used. Okay, for preparation of hydrogen from metals, you are not going to use dilute nitric acid because it is a very powerful oxidizing agent. Because nitric acid is a very strong oxidizing agent, that's why the hydrogen which will be formed over here will get oxidized and form into water. So you will not get hydrogen. That's why you are not going to use nitric acid. So nitric acid dilute is not used in the preparation of hydrogen from metals because nitric acid is a powerful oxidizing agent and the nascent oxygen formed on its decomposition oxidizes the hydrogen to water. Magnesium and manganese, however, react with very dilute HNO3 at low temperatures, liberating H2. So only magnesium and manganese at a very low dilute, very dilute, that is 1% dilute nitric acid is going to give you hydrogen gas. That's since oxidizing action of the acid is much reduced due to dilution. So because the acid is just 1% dilute, so its oxidizing property is reduced and hence you are able to get hydrogen only when the nitric acid is 1% concentration and the metals used are only the two, magnesium and manganese. Lead cannot be used for preparation of hydrogen using dilute acids because lead reacts with dilute H2SO4 and HCl and H2SO4, forming an insoluble coating of lead chloride or lead sulfate respectively, and hence further reaction comes to a stop. Now this is the very important thing, that lead when it is going to, we can see that everywhere it is going to form salts. Similarly, when we take lead over here, lead is going to form salts, but this salt is such that it is going to form a coating on the lead itself. So if I take lead over here, suppose this is lead and I put it into acid, so what will happen? The complete lead ka ye part there will be a coating. So initially the hydrogen is going to be released, but slowly what will happen? The complete surface of the lead will will have a coating of lead chloride or lead sulfate, depending upon HCl or H2SO4 used. And because of that coating, the coating will be a obstruction for further reaction between lead and this. So it will be a kind of a, that's why it is called as passivity. You know, there is a generation of a coating which will make the particular lead passive, and it will not allow the further reaction of the metal with the acids. That's why we cannot use lead, because lead is going to form a coating of hard means covering or a coating or insoluble coating on top of the lead. The next is the general method of alkali. So this was acids. The other one, we also know that all alkalis, that is all hydroxides, okay, they also have got hydrogen in it. So accordingly, if I am using NaOH, now here it is saying that only 3 metals are such that they can be used because they are amphoteric in nature. So the metals which can, so it will be metal plus hydroxide will give you metallic oxide, okay, it will be a complex salt plus hydrogen. So the example over here will be Zn plus NaOH will give you Na2ZNO2 plus H2. Now this is nothing but sodium zincate. So जहाँ पे भी you can say zincate, plumbite and aluminate. These are the only 3 things which can form such a kind of salts. So that's why we have got only zinc, aluminium and lead, which can be used in this particular process. You can use KOH also, NaOH भी use कर सकते हैं, KOH भी use कर सकते हैं, it's not a problem at all. So you can have any of these things. So you can see it is going to give you the reaction will be, plus of course you are going to put some water with aluminum will require some water also to give you the reaction as Na2Al2O, okay, NaAlO2 plus H2. This will be equal to P, this will give you K2PbO2 plus H2. Right, so these are the examples. So zinc, lead and aluminum react with hot concentrated alkali, that is NaOH or KOH, forming hydrogen and the respective salts. So this is the unique nature of zinc, lead and aluminum. Zinc, lead and aluminum are called amphoteric substances. Zinc, lead and aluminum forms oxides of ZNO and hydroxides. For example, ZNOH twice, which are amphoteric in nature, reacts with base and acids to give you salt and water. So ZNOH, zinc is the one which can react, ZNOH is the one which can react with both acid as well as base to give you salt plus waters, and that's why they are called as amphoteric substances. So we can just recap this thing over here, so that when we are taking the activity series and we are reacting with metals, you can see potassium, sodium and calcium reacts vigorously. Potassium reacts vigorously with cold water, sodium reacts less vigorously with cold water, so calcium reacts slowly with cold water, magnesium heated metal reacts with boiling water, aluminum heated metal reacts with steam, zinc red hot metal reacts with steam, iron red hot metal reacts slowly with steam, lead metal below hydrogen including lead has no reaction with water. In case of acids, potassium reacts highly explosive with dilute acids. Sodium reacts less explosively with dilute acids. Calcium, magnesium, aluminum, zinc and ferrous reacts with decreasing vigor with dilute acids liberating hydrogen. whereas metals below hydrogen including lead has no reaction with dilute acid. So this is how the general method of preparation of hydrogen is there. Now we move on to the laboratory preparation of hydrogen, but in the next video.